Okay, so we're at chapter 7.7, which is exponential growth and decay. We're going to model exponential growth and decay, and we're still in A1.4.1. First, we have some vocab. The vocab is exponential growth, an exponential function that increases as you move right along the x-axis. So that's going to be kind of what we saw last section. We saw this line kind of go up. That would be an exponential growth. The other vocab is the growth factor. That is the base b for when b is greater than 1. Okay, so when b is greater than 1, it's a growth factor. It's a growth going up. Okay, so let's take a look at an exponential growth. So if we have, and sorry, this should be b to the x. Should be y equals a times b raised to the x. If b is greater than 1, you're going to have this graph that comes across. If I can draw a straight line here, it comes up and goes up like this. Okay. Now it depends on where you are, but you'll find out that a is going to be where you cross the y-axis. Okay, so if a is 1, you're crossing at 1. If a is 2, you're crossing at 2. If a is 3, you're crossing at 3. But b must be greater than 1, which is just going to increase what you go by. So a graph could go really, really quick increase or a slow increase depending on what you have. But we do have this 0a, which is a key point to note. Okay, so make sure you write that down and understand that. That's 0a. Alright, so we look at problem 1 here. Since 2005, the amount of money spent at restaurants in the United States has increased about 7% each year. In 2005, about $360 billion was spent at restaurants. If this trend continues, how much will be spent at restaurants in 2015? Okay, so we know that the restaurants are increasing at about 7% each year. We know that in 2005 there was a total of $360 billion spent. So in this particular problem, what we're going to do is we're actually going to set this up and to try to figure out what our population will be. So there's a couple ways to do this. Since we started at 2005, we're going to start with that and say, well, let's say 360 billion, so our numbers are going to be in billions. We're going to write our A, and then we're going to write our B. Now our B is our factor. Since they said it increased by 7%, that is our factor, but it has to be bigger than 1. Okay, so it's got to be 1.07. It's increasing each year by that. So what we're saying there is that it's a 100% increase plus a 7%. This would be very similar to Indiana state sales tax. 1.07 is per every dollar. So then X would be our time as we would go through. Okay, so we want to know when time was to start. So 2005. So we're going to say 0. So as I work that out, we get 360 equals A. The 1.07 raised to the 0. Well, that makes 1. So we get 360 equals A, because this makes 1. 1 times A is A. So that tells us that A is that, which we kind of note that this is our initial, initial amount. So that's like where we're starting. So we now have this equation that is y equals 360 times the 1.07, so that's our percentage increase each year, raised to x. So we want to figure out 2015. So if x equals 0 when 2005, then x equals what when we're in 2015? Should be 10. Okay, so we're going to plug in 1.07 raised to the 10th. Now it's not time, so we're not going to move the decimal place. We're actually going to have to multiply this. Okay, so when we multiply this number, you should get in the end 708 for our cost, our revenue. But that would be how much is spent at restaurants, spent in billions. Okay, so you're going to take 1.07 to the 10th and then multiply that by 360. This is definitely something I expect you to do on a calculator, not in your head or really by hand. There's really no point to do that by hand. Okay, so you go ahead and do this one here. Okay, we'll stop there. We'll check our answers at the end, but I want you to go ahead, go on to part B.